Good morning, and I'm delighted to have today Professor John Hall from the Geological Survey of Israel. I'll switch to Hebrew for just a second. אנחנו עורכים סדרת ראיונות לרגל שנת ה-70 של החברה הגיאולוגית, עם ותיקים מובילים של החברה הגיאולוגית לאורך השנים. אנחנו רוצים בשיחה הזאת להנגיש את הפעילות שלך, את המחשבות שלך, את הגישות שלך ואת התובנות. דברים שאתה חושב שכדאי לעשות לכלל החברה ובמיוחד לדורות הצעירים של החברה הגיאולוגית. So let's switch to English and how are you?
I'm fine. I'm 83 and except for my legs, which have been bum for since 1986, then I'm in good health.
Okay, that's great. So I sent you some questions to lead our conversation, and let's start from the beginning. Can you tell a little bit about your personal background?
Yes, I was born in the first week of World War II during the German invasion of Norway. And I think this puts me in a very special category of people who were alive during all of World War II, just beginning to understand what it was when the war was over. In my case, 2 years later, my father, as a 38-year-old civilian, went off to help with the U.S. Army Air Corps groups that would do operations research in order to improve the Air Force. And so he started off in Guadalcanal and worked his way up, and it was only at the end of the war that I remember seeing him getting off an airplane in Boston with only one building there and dressed as a very splendid lieutenant colonel. In any case, I was born just outside of Waltham, Massachusetts, near Boston, on a 14-acre farm. My family had arrived on the Mayflower and shortly thereafter, and we can follow our ancestors back in some cases to William the Conqueror, and even prior to that to the hordes that came over from France to populate England hundreds of years before that. So basically, I'm a WASP, white Anglo-Saxon Protestant, and I went to Phillips Exeter Academy. Half of my graduating class was accepted at Harvard. I was accepted at Harvard, MIT, and RPI. I wasn't an especially good student. My average was about C+ at this famous prep school. Harvard and MIT did not appeal to me. It was just too close to home. My father was vice dean at Harvard Law School. My mother was operating a school that later turned out Harvard's first female head. And so I chose RPI. And at RPI, I was, the entering engineers who took calculus and chemistry, physics, etc. And at the end of the first year, the question was, okay, do I want to be a chemical engineer, a civil engineer, or things like that, or a physicist or a mathematician? And I said, basically, after my years at Exeter, I don't want to wear a necktie. And so a proctor of the dormitory that I was living in said, how about geology? And my first reaction was rocks schmucks. On the other hand, he said, look, the president of this prestigious company is a geologist. The head of the company that did the largest oil spill in the Gulf of Mexico, he was a geophysicist. So, hell, why not? So I, instead of being somebody in a class of 200 or 300 with 30 professors, there were 8 of us in geology with 11 full professors to teach us. And the next 3 years were absolutely wonderful. I was sort of drawn into geophysics by Sam Katz, who fathered Mimi Katz, who has been involved in various things that people at the GSI know about. This was from 1959 to 1962. I had signed up in order to go to work for Chevron in Conroe, Texas, which I understand is not the nicest place to be. So I was set to spend the summer going out to the South Pacific to see where my father had been during the war. I had a pilot's license and also had taken navigation courses and thus could find my way from island to island. Just before graduation, Sam Katz invited Brackett Hersey from Woods Hole Oceanographic Institution to come and talk about what Bill Ryan's first cruise to the Mediterranean had produced using seismic profile. And this sounded very interesting. So I talked with Brackett, and Brackett said, okay, well, if you're not going to go to work for Chevron immediately, why don't you come down to Woods Hole and join us? And I did that the very first thing after I got home. We had a house on Cape Cod built in the 1700s, and it was a 28-mile commute, but I then spent the next 3 years at Woods Hole Oceanographic Institution. This was certainly 2 of those years were before Stephen Avraham finally showed up and began his studies at MIT there. In any case, immediately I went to sea. I was on several cruises with a chain, primarily off Puerto Rico, the Puerto Rico Trench, doing seismic profiling. A 100,000 joule sparker had been set up, putting out 10,000 amperes at 10,000 volts to make an underwater spark. This was because air guns were just coming into use, and beyond that, the use of explosives had resulted in a fatality at Lamont. And so everybody was starting to use something that you could turn on and forget about. So anyway, I did that cruise after cruise after cruise. There was work not only in the chain, but Atlantis II finally arrived, the most modern research vessel in the world. And I was on our maiden cruise to Bermuda, had to introduce the governor's family to all the various things that we had on board. And between Atlantis II and chain, I had a number of cruises also calibrating the Navy sonars, which were located on the ledges just to the east of Bermuda. In the middle of that, in 1963, the Thresher sank, America's nuclear submarine. I was on the second or third cruise of that, and we finally located the wreckage. This was very interesting in that navigation basically was 4 different DECA systems, none of which agreed in Canada and the United States. We were more than 100 miles offshore. The water depth was about 3,000 meters. And to try to figure out just exactly where you were towing a sled that looked like a double bed mounted with magnetometers, radiation sensors together with cameras was quite a job. And having taken the U.S. Navy NROTC navigation course, at RPI, I was familiar with celestial navigation as well as electronic navigation. And this was one of my jobs working together with the camera crew and developing the various films that we're taking.
So this was after your studies or during the...
Oh, no, this was 1962 on. And back at Woods Hole, Brackett Hersey asked me to try to summarize years and years of work that they'd done for the Navy, setting off 1-pound charges in the Mediterranean and the North and Central Atlantic to measure bottom reverberation from these explosions, which could confuse sonar signals if you were looking for submarines. During this time also, although I had taken a programming course at RPI in 1961 and seen a computer, at Woods Hole we had a computer that belonged to the oceanography department, which allowed me to start the first work in Fortran. This was a simple computer itself, no monitor, anything like this. When you ran a program, you knew when you were in do loops by the static of the radio that was on top of the computer system. After that, they got IBM systems, and I did an awful lot of programming and calculation for digitizing all the graphical work which had been done 10 years earlier for bottom reverberation. And ultimately, before in 1964, spending a summer at Woods Hole, I computed or I finished the main report on summarizing all that bottom reverberation. At sea, it was very apparent that if I continued like this, I would be writing the 100,000 joule sparker all the time, or assisting with the magnetics, or finally a computer had been taken to sea on one of our cruises to the Puerto Rico Trench to actually read the Lacoste and Romberg gravity meter. I'd been involved in the navigation as well, and so I decided, okay, I better go off to college. Well, where to go to? Close to home again was not a good idea, and so what the heck? Let's try Lemont, because Bruce Hazen would come by from time to time, and various other people who the Woods Hole people knew very well. They had sort of seeded the senior people at Lemont, and so I went down to Lemont in 1965 and headed straight for my PhD. And I had worked with magnetics, I had worked with gravity, I had worked on the navigation, I had worked on the echo sounding, I had worked on the the photography, I had worked also on sub-bottom profiling. So what to do? These departments were all out. On the Arctic, we have a drifting ice station that belongs to the U.S. Navy. Here's somebody who can do all of it all alone, maybe with one or two other people. And I went to work in the Arctic section. It sort of reminds me of the section of a hospital where the real crazy guys are. In any case, I was in there until the time that I finished my PhD. 1966 was the first summer that I spent 4 months up there. I brought up a seismic profiler, which was based on a sparker. I had made 2 recorders from Korean War fax machines, one with a 10-second sweep and another one with a 2.5-second sweep, and put together all the amplifiers and everything else there. And we went up, and the ice station had been occupied since 1962. Although it had been operated during the International Geophysical Year some years earlier, it had gone aground north of Alaska, and it was of no interest. It was about the size of Manhattan in New York City. It was about 160 meters thick of glacial ice that had come off of the island right next to Greenland, Ellesmere. So in any case, I flew out there and began totally revamping everything that was going on, all the programs, and started something which continued in that way right straight through 1970.
The station was relatively new when you came there.
It had been operated by other people at Lemont. Woods Hole had some people up there, but it was a new camp, a new runway, and everything that they had set up in 1962. The population during the winter was 16 to 18 people. The summer population could go up to 30 or more. Usually there was a station leader who was appointed after getting off the airplane. And various Canadians groups were up there, and also biological groups doing their stuff. We were the main ones doing geophysics. The USGS also set up a completely new system to do heat flow. And during that summer, we got the routine going, and I learned exactly what needed to be done. So returning back to Lamont, the whole process of going back through the daily echo sounding records, which were done on a rotating drum, the seismic profiles that were continuously being operated. I should point out that when I arrived up there with the original boomer system, I was told that I could use no more electricity than the camp toaster. This was a toaster for 4 pieces of bread. The net result was, since we were going so slowly, and since somebody had put up a EG&G boomer system there, which with the large discs, aluminum discs, which were thrown out electromagnetically, was impossible to put through a hydro hole. I mean, we were working in bay ice that was 6 meters thick, and to have something that you could pull up from time to time to check the transducers, that was impossible. So instead, the first request was, can you send me many, many resistors? And we rearranged the inductive circuitry of the boomer system so that it would slowly charge over a period of 5 minutes, and then it would put out a underwater spark, which on the 2 disc bender hydrophones that we had just hanging down, draped in the water, sounded like a phantom on afterburner coming out of a ravine. It was one hell of a blast, and it was also something that slightly disturbed a group from General Motors Defense Research, who were operating a 60 hydrophone array in a circle to look for Russian submarines and the background noise of the Arctic Ocean. And basically, with the 5-minute schedule, we worked out something whereby they put their fingers in their ears, figuratively speaking. Then the boom would go off, and the bang, 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 multiple reflections, good reflections, on the recorders down to 2.3 seconds under the bottom. And after that, they would try to listen to, were there any returns from the sparker pulse, and then what was the background noise in the Arctic. In between, I was working on the past data, writing programs for our IBM 1130 computer, and also training new people to go up there, new meat, so to speak.
So you had nonstop work.
Yes, very definitely. And this is what I was born for, as you will probably see. In any case, I discovered that with young college students, there was no way you could find somebody with technical expertise and say, okay, we want you to go up there for 8 or 9 months. It's going to be the winter months. It's going to be cold as can be, and it's going to be dark. Instead, I found with college students who were looking for something interesting to do, and some of them just sort of quit college and did it for a couple of years. Would you like to do something that you can tell your grandchildren about? And this somehow lit something in their minds that said, hey, wow, this is kind of interesting. And so we had a whole slew of people like this who in some cases went up 3 or 4 times. And they had to be trained, having never seen anything at the ice station, to basically, when the R4D or the DC-3s made in the 1930s landed on our airfield, to basically get off and start running, keeping the data going. And quite often they would say goodbye to the person who had been up there for 3 months, who was just getting on the airplane, and say, well, let's go home. So anyway, these people were successful. The program kept on going until 1970. And as a matter of fact, until 1974, when the ice station was abandoned, because it was just sort of sitting off of northern Greenland, not going anywhere, shallow water. And ultimately, in 1974, they pulled it off. And so this was basically what I was doing all during that time. My PhD thesis was the marine geophysics of the Alpha Cordillera. This is a large ridge, which actually the drift track that was included in my thesis was almost a third of the deep Arctic Ocean. This was a success. It told us something about this ridge based upon its extension down through the Labrador Strait. I concluded that this was a old spreading ridge which had died out before the present Mid-Atlantic Ridge had opened up. This was completely wrong. It's later, apparently, I must say, basically, since that time, nobody has been back up there to do things. Icebreakers have poked in, but the ice generally in that part of the Arctic is 4 to 6 meters thick. Icebreakers can't go there. So anyway, during this time, I was living on Riverside Drive, dating 2 girls who were upstairs, or basically servicing them, feeding them from time to time and showing them Broadway shows. And then they finally decided it was too dangerous to live on the west side. So they moved to the east side, and they sublet to my future wife, an Israeli who had just received her PhD in solid-state physics at the University of Delaware. Well, our relationship went up and down and up and down. And then in 1967, when I was due to be up there for 7 months, we sort of called everything off. Except, no, that was during 66. So after coming back 66 with a time change of 10 hours or more between Alaskan time and the East Coast, I wound up on her doorstep again. So things picked up again, and when I went up for 7 months in 1967, it was agreed that upon my return in October, we would get married. And this is after the whole hurdle of, but I know you won't be ready to go to Israel. And I said, why the hell not? So that's how this wasp wound up coming to Israel, married to an Israeli for some 3 years before I arrived. During this time, the question was, what will I do in Israel? And so I first came in October 67, right after we were married. I was investigating what was going on in Haifa. I had heard that things were going on in the Geological Survey. Nothing was really determined until 1969 when I came back, and the question was still in the air. Is this going to be part of the new Hakayamim Ba'agamim IOLR in Haifa, or is this going to be the establishment of a new division at the Mechon Hagiologi, which had moved from the Spanish opposite the old city of Jerusalem to where it was for the 35 years that I was there, in Schneller, right up in Masharim. And when I came in 1970, in the latter part of December, within 2 days, I had gone to work. Yoahi Ben-Nun had come up. He immediately wanted to contact me, maybe to yank me off to Haifa. I remember him saying all the time, here, I'll find a place for your cases to be while you get settled. In any case, I started Ulpan. Within Beit Giora, where we lived until we bought a house. But again and again and again, I seemed to be in the back of a stake body truck, dragging stuff up to Haifa, getting onto the Shikmona, and going to sea. So that began the whole program of the Marine Geology Division. Yaakov Nir was there, Gidon Almogor was there, and we had technical staff who had learned various things about going to sea, but by and large, not that much had been done, and this was shortly after the Shikmona had been bought from Germany and was starting to operate offshore.
And how was the transition from all you've done in the Arctics to Israel, how was it professionally for you?
I would say exactly the same. I mean, I lived in what we called the palace, like a 64 or 40-foot long trailer with about, I think, over 100,000 bits and pieces there, recorders going all the time. As soon as we had a house in Sfontalpiot, I made a room that was my office. This is where my library was kept. During my 35 years at the Mechon Geology, I borrowed office space here and there. My first real office was in the basement, unpainted, of the chemistry building, and right next to the receptionist. And it was clear that if I was going to get anything done, the best thing was to have an office at home. And I must bless the Mechon Geology that for 25 years, they allowed me to work at home. On the other hand, there were regulations that said you are not working for the Mechon Geology unless you punch in twice a day. And so the days when you could drop by, punch in, punch out, and see what was going on were no longer there. And when I moved to Moza, which was a bit longer travel time to get up to the Mechon, the easy solution was around 6 o'clock in the morning, I would go up there. There was no traffic whatsoever, punch in. And 10 o'clock at night, when I finished what I was doing at home, I would go up and I would punch out. And they never paid me for the hours that were indicated there, but they never docked me for a day. And I bless the Mechon for their easygoing attitude. I think many of them didn't really know what the hell I was doing. Bibi probably covered our Bibi, David Neve, who was sort of my father in residence, and who helped me so much in what I learned, basically with the rules of the Palmach. No lying, no shenanigans, whatever the job, let's find a way to do it. Do we have to go through unrealistic means? That was also possible. I was also lucky in that my grandfather had been president of the American Chicle Company that made chiclets from the 1910s on. He had a sole child, my mother. And when he retired, there was a fair amount of money there. And all of us kids were, over the years, set up in such a way that when we died, there would be something for the next generations. And so the nice thing there was, although I never got a grant, I proposed once for 100,000 shekels or lirot, or the old shekels, to put together something for all the mappings that we'd done along the Mediterranean coast. No, it was turned down. So anyway, it was done. And bless the Mechon, this was possible. To begin with, Bibi was, with help of K.O. Emery and other people at Woods Hole, an air compressor had been obtained, air guns had been obtained via Woods Hole, and Danny Argas and Rami Badmon were very capable of going to sea, keeping this equipment operating. And so we made the first exploration profiles, getting records down to several seconds. Down further west of Aristosnes Seamount, south of Cyprus, and up to the Lebanese border. 1982, when Tzahal went up to Beirut, we, in November, were able to do a complete mapping up to Beirut along the offshore and the margin, with a number of deep seismic profiles that were also done. We were harassed continuously by the 13 UN ships, which were sitting offshore, but we certainly got it done. During that time also, there were various cruises with the Navy. Because of the rescue buoy of the Bacro, the submarine that sank in 1968, their assumption had been that maybe with a delay of one day getting into Haifa, they had perhaps gone down to measure the radars off Egypt and perhaps had sunk there. So we had done a fair amount of mapping down there looking for the Bacro. Other work with the Navy also was for underwater sound transmission and especially for listening arrays off Haifa. During this time, I had been in connection with what the Brits had done in the Red Sea, what they had done basically to Cyprus, around Cyprus, and later what had been done in much older surveys. World War I surveys had been done off Aqaba, for instance, and the same with World War II, just in case the Suez Canal had been taken by the Nazis. I got to know all these people who in Britain and France and other places had done this kind of work, and through a program through the United Nations and UNESCO called the International Bathymetric Chart of the Mediterranean, we had regular annual meetings, get-togethers with the Russians, with the Germans, with everybody at all kinds of different places around the Mediterranean, with connection to all the institutes who were working. By hook or by crook, basically, we ultimately finished all the 6 overlays which were planned. We were the only IBC which succeeded. There was the one for the bathymetry itself with 200-meter contours. And this was the 30,000 earthquake epicenters. The plio-quaternary sediments laid down since that time, all based on sub-bottom profiling. The Bouguer gravity, and also the magnetics, and I did not find one of the postcards. After these maps came out, everything we had done was put out in the form of postcards or posters or other things like this, which at meetings of the Geological Society, I would have printed. I should point out that only one diagram that we had was done by the Sertut department at the Mechon Geology. Following Lamont, I always had a light table at home. Behind me is one which is 8 feet by 4. This was, of course, for transferring data over a light table from place to place. Ultimately, digitizers became available. I'm very thankful to Hebrew University, for the CDC 6400 computer that they had, which commuting back and forth from Sfontalpiot to the university, we'd punch up cards, run things, run back home, do something, come back, get the printout, and up until late at night, just running programs, and ultimately keep punching data and bringing the marine geology department into the computer age. Other work that was done when I first arrived, I was handed a tremendous survey which had been done of the Tiran Straits, which of course was the one of the reasons for the closure of the straits being the start of the Six-Day War. And all of this data had been done with decahyfix, with improper sighting of the various hyperbolic transmitters and receivers and operation of the ship, digitizing all the records of that at a digitizer that the geography department of Hebrew University, which used to be located where the geology department is today, the Department of Earth Sciences, They first bought a digitizer, which was well used. After that, they bought a 1 meter square plotter, which allowed many of our plots to be done. And this sort of went on until the mid-'80s when the first PCs came out. At an Arctic meeting in Calgary, Canada, I suddenly discovered that the IBM advanced system came out. I bought one of those. Ultimately, GTCO came out with a digitizer. And after that point, I was basically independent, running stuff using Fortran and going from computer to computer to computer. And my estimate today is that I purchased over 130 PCs for various projects. I mean, as soon as the PC revolution came around, Ron Bogosh discovered that he could get 50 people to sign up for a mass buy of the PC XT, not the AT. And so this is what more or less converted the Mechon Geologi over to PCs. Just about the time I was put in charge of putting a VAX at the Mechon, and thanks to Dina Ashkenazi Zal, the Mechon, to put it nicely, removed the typist staff, which I think there were over 100 people at the Mechon when I came. When I left, it was mid-'60s. And all the typists, secretaries, and everybody else went out, and everybody was fitted with a monitor together with a keyboard and Boston Business software for working in Hebrew or English. And so this ultimately was the computerization of the Mechon Geology.
What year was that?
This would have been 85, 86, 87, this time period. Okay, what brought me to the field, we've gone over to that. Researchers who had influenced me, I've mentioned most of these. Bibi was not a technical person. He had awful handwriting, but every paper that he put out, I sort of massaged the English and read his handwriting, typed it up, put it on the computer, allowed him to go back through and make more changes. And ultimately, we worked a number of years on our Pelusium paper, which ultimately was 80 pages in the third book that we was put out of our activities. In the 90s, I was contacted through the Russians that I had worked with and told that Gleb Udintsev, who was one of his the primary geologists, geophysicists, who had started the Russian programs right after World War II. He was a hero of the Soviet Union. He came and visited me with Valery Kreshninikov, who I discovered was a Cushman Prize paleontologist, but the two of them had been the chief scientists of 2 years of cruises of the academic Strachov from Syria and the Latakia Ridge to west of Eratosthenes Seamount, included seismic profiling, which had been done, and using a Finnish multi-beam sonar with 15 beams. This was unbelievable, absolutely unbelievable. They basically had only the old type of Navy navigation satellite fixes, perhaps 4 or 5 a day. And so between these fixes and the headings and speeds, I reworked all the navigation to try to figure out how to put in the bathymetry, digitize the seismics, and ultimately with Valery here for upwards of a year, we put out the book on the work of the academic Strachov. And basically this took care of everything that had been done off of Syria and Lebanon. And it was very useful, and it was the raw material for some of Zvi Ben Avraham students at Tel Aviv University. Other surveys, very soon after I arrived here, in 1971, or no, 72, I guess, there was a cruise of K.O. Emery's Eastern Atlantic Continental Margin Survey. And the last leg of that was basically from the Spanish islands off Morocco, working their way up to Portugal. And so I was on that cruise. We negotiated back and forth on the first method they had of using the early computers, record data digitally. Ultimately, we tried to get $90,000 from the Israeli government to buy a complete set. Probably, fortunately, we did not get that. As I say, no grants were ever given. It was usually a matter of taking a tramp on somebody else's research and trying to get more data. During the 70s, with people from Heker Yamim, there was a thought that, okay, we have done the Tiran Strait. Maybe the time has come to do all of Mifratz Eilat. In the meantime, we had finally gotten the United Nations project for Zipsev mining, which was going to try to develop a ship for doing calcareous gravel mining offshore so that we would not have great big quarries all over the country. This provided us with a Dutch engineer and together with a Mini Ranger set of transponders so that our navigation was better, and a shallow seismic uniboom system together with echo sounder. So using this, we laid out Mini Ranger stations to use along the Mifratz Eilat. And about this time, Tzvi returned, checked into Heker Yamim, announced that he was going to go down and do it on a ship whose name I do not know. And so the survey was done of the Gulf of Eilat. And then Tzvi handed me all the data and said, can you work it out? And so this was all worked up, and ultimately we put out that color chart, which was the first time I had actually printed a color chart with different shades of blue all done. And in the process, learning all the printing stages for chart production. 1974, also we'd gotten to the point where, okay, Bibi did a survey of the southwestern part of the Dead Sea. Why not do the whole Dead Sea? And so in 1974, we decided, okay, we have the Mini Ranger. We do have echo sounders, 30 kilocycle echo sounder from the laboratory down in Eilat, together with the Sparker, which was fine. And Sparker is beautiful for working in the Dead Sea, together with the boomer system. And so I put all the equipment in my workshop in Swanthopio and into the back of my old Volvo, my 1970 Volvo, and drove down there. And in 2 days, we produced a research vessel with a second deck on it that had a machine gun together with a reservist underneath a tent, and basically places for all our recorders and generators, together with the magnetometer, together with all the other equipment we needed. And we had our Danny Argas and the crew on land who were moving our navigators, our Mini Rangers around. And fortunately or unfortunately, during that time, this coincided with the invasion of the Greek side of Cyprus by the Turks. All eyes turned to the island of Cyprus. We had proposed in our the $10,000, I believe, that we got from the Dead Sea Works to do this survey, that we would go out to the Green Line, which is the fictitious line between Jordan and Israel, which runs the length of the Dead Sea. With everybody looking that way, we just kept on going. Bibi would look out. If you go to the Neve Center on his name, the symbol of that is him looking towards Jordan with magnifying glasses. And as he said, we never saw the Green Line until we saw the vegetation on the far side. So we would turn around and we would come back. And we did a complete survey of that, except for a storm in the middle, which lost us a week. Everything was drenched in Dead Sea water and had to be washed down in the springs in En-Gedi. So that completed that. All the seismic profiles and everything were put up in the reports that came out. And basically, we had completed the Dead Sea for that. Sea of Galilee was done late in the game. I was working on the books during the 90s. I had 4 sabbaticals, 2 of them. My wife had gardens. She did not want to leave Israel. So one was done with Cytex, which was very important in that I used some of their scanning abilities before I had my own scanners. This was the beginning of working on the DTM of the country. DTM of Cyprus was done far later. This was during my last sabbatical at the University of Rhode Island. This was very interesting because Bob Ballard had his center there, and they were doing all kinds of work with multi-beam. This was going to be absolutely great. When I got down there, all the Bob Ballard stuff had been taken off the Nautilus, was being kept there. We had 2 small children. And so I equipped a room with computers there. And during that time, I had taken all the 1 to 20,000 maps of Cyprus with me and digitized all the contours there. And beyond that, through the connections with the UK Hydrographic Office, I had gotten all the 1950s and 1930s surveys that were done on all the continental margin of Cyprus. So ultimately, a 25-meter grid was done of Cyprus. I retired in 2005. My last sabbatical was at the University of New Hampshire, which today is the primary center for all the United States' mapping, for JEPCO's activities at sea, together with the activities of everything to do with multi-beam sonar. And this intrigued me when I finished with the time spent at UNH. As of 2000, I finally determined, the time has come for us to buy a multi-beam sonar. The cost for the basic multi-beam is $500,000. I went to talk to people in New York City. I got $500,000. I flew to Norway. I bought the system that we put on the Etziona, and this operated then for the next 10 years or so. And I met Ronnie Sadeh, who had been done the courses in Italy for hydrographic survey, the first level. And he was the person at work together with the fine crew from Hekayimimba Agamim. Some 162 days of work the Etziona basically did much of our offshore out to our maximum depth of 700 meters. About that time, the operations of the oil companies offshore realized that if you're really going to understand the weird things that we had seen on our cruise of the Meteor, with their, not really a multi-beam, it's a weird one, fore and aft. Anyway, the kind of things, these 13 channels that are a kilometer wide, 30 meters deep, and just wiggling back and forth, back and forth, back and forth from Israel's continental margin out to the deeps of the Mediterranean. So ultimately, the oil company work began to come in. In the meantime, the French were working on multibeam as far east as the Nile cone. So bit by bit, we were filling in what had been done with single beam and preparing what would go into the European communities, E-mode-net ultimately. Today, what has been done with the Batgalim, which was basically, there's a story behind that. I think I have time for it. I once asked Benny Begin, how did it ever come about that you got the initial money, 20 million shekels, to buy the Batgalim? And he told me, well, I was part of the government and I used to sit in on the cabinet meetings and I would be quiet and I would listen to what all the Sarim were talking about. And finally, one day when everybody was putting in their budgets, I put my hand up and Bibi turned around to me and said, okay, Benny, what do you want? He said, I want 20 million shekels to buy a research vessel. And next item, in any case, looking around in Turkey, Gidon Amit and Ronnie and others, and Gidon Tibor, who was a very important, very, very important part of this, went looking for a ship until they discovered the Batgalim, which was one of two ships that the Israeli Navy were using for accompanying submarines when they were doing exercises offshore. And it was extraneous. They were able to purchase that. And Gidon ultimately got sort of signature ability through the Misrad to basically equip that with the help of the University of New Hampshire people to the ship that it is. And it is officially one of the 7 ships of the university fleet looked after by UNH in the United States, but it belongs to Israel and it's sitting in Haifa. And while its capabilities are absolutely fantastic, unfortunately, even with a very low daily price of $15,000 or $20,000 instead of $60,000 or $70,000, it's not being used that much. It would be wonderful if we used it more. During this time, I was also involved in the mapping of the International Bathymetric Chart of the Arctic. And it is now in its 4th edition under Martin Jacobson of University of Stockholm. He is a student who got his PhD at UNH, where I did my sabbatical in the early days of the 90s. No, 2000. We had various meetings. We put together every bit of data we had. We had been doing contour maps ultimately. Up until the end of contours, nobody had written the software basically for gridding. And as soon as especially Global Mapper came out, but prior to that time, also the other program for doing GIS, long before GIS was official. This allowed you to do gridding and ultimately to print out in color, especially with Global Mapper, the kind of grids you had. So we had meetings in Calgary, we had meetings in Europe, we had meetings elsewhere in Russia to put together the grids. And in the 4th edition now, it's been out for a number of years. I'm sure the 5th edition is underway. It was as of 1990 something when the first edition came out that Bruce Hazen had written me a letter and said that, this was the first one that Lamont put out and that he had named a seamount after me up on the Alpha Ridge. This was something that was 700 meters high. I had not thought enough of it to name it. Ultimately, it was called Hall Knoll when the newer maps came out with stuff from people who were operating out of Greenland. We discovered that it's part of about 4,000 square kilometers of area, and Hall Knoll is there. You can look it up in Wikipedia, and as well as people from Lamont who have their names all over the world ocean map. There are only two of us, and one of them is the heat flow fellow who passed away, and later Lamont ship was named after him. So it is a seamount elsewhere down in the Chukchi Cap, and that I made the first seismic profile across in when was it? It was 65.
Wow, that's amazing.
Okay, now,
So
the Arctic, the whole thing was, as more information came out in the Arctic, the Canadians had a temporary station. They airlifted people out for several weeks. They did some cores, and the Lamont group had been taking a core a week and sending these back 3-meter long cores, and the analysis was showing 1 meter every million years. The Canadian cores were showing that there were approximately, these were long cores, and that there was something like 15 meters of sediment, and then after that they were getting Cretaceous sediments between 65 and 67 million years old. In that, you had 30% organic carbon, and basically it was deposited in a very saline, shallow Arctic basin. This is the underlying part of 25% of the world's petroleum is within the Arctic basin. So this was exciting, and the question was, nobody has been back to the Alpha Cordillera, or the Alpha Ridge. And Yngve Kristofferson, who had gotten his PhD, he's 2 years younger than I am, but he'd gotten his PhD, I think 6 or 7 years after I did. And he had been working in the Arctic with drift stations, but basically the Lomonosov Ridge and those areas. And I got together with him on a medal ceremony for the fellow who was in charge of all the U.S. Navy projects in the Arctic. And we had our first meeting. There was another meeting at a Arctic meeting in Calgary. And then finally he contacted me and came to the United States. And we were talking about this, and he said, you know, I was at Universal Studios, and the kids were all excited, and nothing caught my attention until this small hovercraft came buzzing around through it. And I said, I suddenly thought, my God, this is a way that we can get back up on the Alpha Ridge. So this is the result of the most expensive failure that I've had since 2000 and, well, the decision was made 2005, 6, 7, something like that. We ordered a $1 million hovercraft in 2007. It was delivered to Svalbard, Spitsbergen in 2008. And between 2008 and 2020, Yngve was running a number of expeditions up into the Arctic, including in 2014-15, a 50-week, 5 crossings included of the Lomonosov Ridge while doing digital seismics with an air gun every 25 meters, firing it. And so staying awake day and night, cleaning the air gun stuff with alcohol at 60 degrees below zero. This was done. The last work was 3D seismic together with people from a Norwegian company putting out a whole bunch of sensors. Unfortunately, you had to swim from ice floe to ice floe. We were finished for work in the Arctic. You could no longer walk around on the ice floes. So 2020 was the last year. It was then brought back. Extensive overhauls were done on various things. And then 3 years ago, there was a suggestion from a touristic company, White Desert, that say, maybe you'd like to bring the hovercraft to Antarctica. We will pay for its shipment to Cape Town. It stayed in Cape Town for over a year trying to solve several problems with it. It was rebuilt, it was repainted. Then winter, well, let's see, a year and a half ago, it was then taken by the Agulhas 2, South Africa's icebreaker, and lifted onto the ice shelf just opposite Africa. And it has been sitting there for the past Antarctic summer, where we discovered there were problems with the adjustable prop. This was finally fixed with the help of an A&E mechanic who was looking after the various aircraft that White Desert are using for high-end tourism in the Arctic, and supplying all the flights for the Russian and Norwegian and other stations on that sector, which is Queen Maud Land of Antarctica. The program for November is to see whether or not it can get to fuel dump at 83 south. It is now sitting at 59 south, and trying to see whether it can get up to about 2,000 meters altitude. Hovercrafts are built for flat things. And the long-term idea, if fuel will be available, and last year's test showed that we're using half as much as the tractors used in getting around in Antarctica used. There is the thought of the people who run White Desert, who are all Antarctic veterans who have skied across and done all kinds of things there, who now introduce Antarctica to people for 8 days for $98,000 per head. Wow, yes. If fuel is available, the thought is to get it to the South Pole, which is the height of Hermon. 2,600 meters, and it's a distance of 1,600 kilometers to go from where it is now sitting on a snow pedestal to not get snowed in during the last Antarctic winter.
You spoke about so many adventures and experiences and achievements. So what do you think is difficult and complicated? Where do you think people should invest their time, and which challenges?
My real feeling when I get to the מכון הגיאולוגי in its glass palace in Gav Yam, the 12-story science center that it is at the end of, that it's an echo chamber, and you have to go looking for people. Nobody seems to know what anybody else is doing. There is no coffee break. There is no mixing. The get-togethers that we have had, a few of the retirees show up. They are basically unconsulted. The people who are still there, who remember us, I mean, this is 18 years on since the last time I clocked out. They're handshakes. They're, how you doing? You're still alive. Some of us are dead. But this kind of thing. But everything seems to be primarily laboratory or seismological center oriented. And the fact is that this is to our credit in that we who are retired did the tashdit part of energia ve tashdit. Now, I did not mention the DTM. The DTM that I did, the 25-meter grid of the country, was started when a fellow named started historical productions to produce things for religious groups in the United States. And he had started off with one of the best sectional Landsat 3, I think, passes over Israel following heavy rainstorms that completely cleaned out the atmosphere. He produced these maps together with French satellite meter data at grayscale at 10 meters. So we took the 30 meters and reinterpolated, 9 pixels using the grayscale to 9 shades of the color scale in the Landsat to make the imagery that you see at Hebrew University, which is all the posters that he had and the strip. And this started a whole business of trying to introduce to the geologists what was going on from the launch in July 1972 of Landsat 1. And so I was producing all kinds of things with satellites all along, but Richard Cleve, with his historical production, said, I really want to fly through this data. And for that, you need topography. And so, with the ability to scan the bromides, the black and white maps, which are the basis of Agafamedidot's 20,000 scale maps of Israel, there is then the possibility of producing a 25-meter grid. The first condition, and mind you, a no-cost contract took 9 months to negotiate between Israel Energia and Agafamedidot. And the first thing said that the data can only be on my computer. Hence, the 5 people who worked with me all had my computer with them too. They later kept them. The second thing was that there will be no digitizing of black lines. Well, this was a problem until suddenly it hit me that the PCAT came along with a wonderful monitor that was 350 pixels high and 480 pixels wide. You could basically flood a new color there at 300,000 pixels per second. So what happens if we take the bromide scan, black, 100% black on 100% white, scan that, and then go through and make 7 screens wide, 14 screens down, and you have covered one of those 120 map sheets and all the maps that the Agafamedidot puts out, which go from Lebanon to south of Eilat. First, this was done in BASIC. Then I did it in Fortran. And the software there basically consisted of, okay, we scan a map, we break it into the screens. Each one of the vertical ones are going to be a 5.5-inch floppy. Every box of floppies is going to be 14 of these things, and it would go to somebody who would then get $5 an hour on a computer that belonged to me, working, babysitting at night, doing other things, working weekends, all of things like this. Ultimately, 5 other people worked with me, 12,000 hours. It was 50 hours per map, basically. And everything that they did on these screens, I then wrote the program to put the screens back together, to work with the colors. The whole idea was you flood a color between a black line. And I ask you, what manual did you read to ride a bicycle? No, you climbed on it, you fell off. You climbed on it, you didn't fall off. You moved, you were stable. In this case, the people who began just went through and filled in the pixel or multiple pixel holes in the black lines. So later, when they learned much more things to do on a 16-button cursor on a large GT code digitizer, they could start filling in color and then moving screen to screen, half a screen in memory on that type of monitor. And by 1993, after 6 years, we had produced the grayscale and been able to put it out. The first map that came out was done in Fortran, figuring out what the light variance would be on every 25 by 25 meter thing. It was 83 hours of time on a IBM 486. You know, the funny thing was Shirion would ask a company on the Golan to make themselves a 3D model, and they would give them a 50-meter grid, which is what a Gafamedidot has, except for the 2-meter grid from LiDAR, and with jumps of 1 meter. Now, our vertical jumps were 10 centimeters. And so every single time they would get an order for a map, they would then contact me, and I would give them the same file to put into a computer numerical control machine, to then take a block of plastic and carve it out so that for Shirion, you were dealing with the whole business of how can I go from A to B with nobody seeing me from any of these other places.
Okay, so now I want to ask you, what is your message to the Geological Society?
Trouble is, I busted my hip 3 days before your last meeting, and so I don't know what the modern IGS is.
More or less the same.
But, you know, the funny thing is most of the conversations that I had were the parents of the students in Neve Center that I started in 2008 at Hebrew University. They were very curious about various ideas of how you could do things with Rachvanim, with the drones, with this, that, and the other thing. And what can you do with ground-penetrating radar? All the tools and seismic tools that we have at the Neve Center at Hebrew University. I should also say that all the places that I worked, I had a library. Your department at Haifa University got basically the innards of 200 meters square of shelving in 2 compactuses. The maps that were in over a dozen 8-drawer map cabinets basically are in the whole map archive at Hekerimim Va'agamim, which is basically the only social room where you can go in, sit down, comfortable seating. And I hope sooner or later we'll have a website like we had for the Neve Center, where you have an idea of every single map I could get a hold of for the areas in this part of the world that I mapped. And we're talking about Arctic to the Caspian, Black Sea, Med Sea, Red Sea, Arabian Gulf, Northern Indian Ocean from Madagascar north, Persian Gulf, and everything over to Sri Lanka.
Wow, that's amazing.
All 10 of the deep African rift lakes. 100-meter grids were made for the JEPCO project. They haven't put those into the grid yet. I mean, they've had the data for 10 years at least, together with Lake Baikal. I have an idea of what sort of stuff is out there, because much of the idea of the Neve Center is visualization working in 3D, either with the radars, with the LiDAR. The most expensive thing we had was an XRF, which was against my $70,000, just for something you could point 50 seconds of radiation, and all of a sudden you knew everything that was there. And all my life, since beginning to build the first mass spectrometer at RPI, I've hated geochemistry, because there's always a log normal curve based upon some of the isotopes of things that we never looked at on the chart of the elements. To get out of this micro world and see what's out there.
John, thank you so much for this amazing conversation and all your contribution. And we want to see more and more.